Hello, geometry. This is the third of 3 review videos that I'm posting for the final to help you get ready for it. You should be watching this video on Monday, June 14th, and you should have found this link on Canvas. And I want you to go along with this video with the self-paced Lumira. And what I recommend you do is that you pause the video, try out the problems, and then go ahead and play it, and I'll try to solve it for you. Let's start with this very first activity. It's the memory test. I know that everything seems really, really small, but all you have to do is just kind of look at the figure and try to find another one that looks just like it. And so I'm just going to click on a few of these. And there is a pattern to it. There you go. And it'll stay up. So go ahead and work on that. And then when you're done, let's move on to that next slide. All right, so let's go ahead and move on to that next slide. All right, for this one, you're going to have to do a little bit more work. You're going to do some matching. I recommend on a problem like this, take care of the low-hanging fruit, the problem that you think is the easiest for you to solve. Like for me, I think AA similarity is the easiest one. So let's take a look at it. And my most natural one to look at is this one right here. Could that possibly be AA similarity? Well, how am I going to go about solving that? Well, if you notice that both triangles, angle B and E, they both have 81 degrees. And A and D, they're a little bit different, right? But are they? Let's go into that DocCam. Let's go into my DocCam real quick. We know that the entire triangle adds up to 180 degrees. Just subtract the other two. So let's see if I can find it again, right? So we have 81. We're going to go and subtract 81 from 60 and see what's remaining. Okay, because we're not sure what's going on with F and C. We got to figure out what's going on with F and C. So 180 minus 60 minus 81 is 39. That doesn't match 40. So that's not it. But guess what I just found? I just found a triangle that is not similar. If you get it wrong, it's going to give you those X's. So just to get you started, I recommend that you work on the low-hanging fruit. Let's see if we can find another AA. Look at this one over here. Notice the angles. Well, let's see here. Pick one of them. 100 minus 45. You take that away from 180, 100. Let me do this again. That leaves you with 35, which is that other angle under the triangle. So we found a second one. I recommend you just spend some time, use some paper, some pencil, and try to solve these. So I'll go ahead and pause this video. I'll let you try the others. Okay. So hopefully you had some time to try the others. Maybe you got frustrated, maybe you didn't. Let's see here. Let's look at this one right here. And I'm going to have to put my glasses on for this one because the problems are small. I can see that these are AA similarities, so they have to be similar. And it looks like I'm looking for a missing side. So I'm going to try to use scale factor to help find that missing side. I know the two vertical pieces have to be proportional to the two pieces that are on the long leg of this right triangle. And the long leg of that right triangle happens to be 24 plus 12, which is 36. And it has to be proportionate to 12. So I'm going to die 36 by 12. That gives me 3. So our scale factor in this case happens to be 3. I'm going to go ahead and multiply that by 1.8. And that gives me 5.4. And there's nothing up here that says 5.4. So I think we're going to have to move on from this and try to figure out another one. What is 5.4? Thinking 5.4 is a bigger one. That's 1/2. And I think these two are going to be the same because I can see 27 divided by 18 is 1.5, which is 1/2. Let's see if I'm right. Oh no, I'm wrong. It's got to be side angle side. What is another scale factor I can find? That's 3/2. 12 divided by 8. There you go. Our side. It's got to be these two. And then scale factor, 1/3. Okay. Let's go ahead and move on to the next slide. So the first set of 3 ordered pairs form a triangle. Determine whether the second 3 corresponding ordered pairs form a similar triangle and justify your answer. Well, we have 2 ordered pairs. Let me write these down. 2, 2, 4, 2, and 4, 4. And then we have another set of coordinates, and you can either plot these out, you can go ahead and do that, or you can go ahead and just write them out and figure out the math here. 4, 4, 8, 8, sorry, 8, 4, and then 8, 8. And there's 2 ways you can go about doing that. And I wrote these down on a little side paper just so I can track it. You can go ahead and plot it if you like. So where's 2, 2? 2, 2 is, I'm going to use a different dot. It's right here. 4, 2. I'm going to go 4. I'm going to go up to 2. And then 4, 4. I'm going to go up to 4. So there's our first triangle. See if I can put it in some kind of lighter color. There's our first triangle. Our second triangle is at 4, 4. If you ever want to undo these, just click that. 4, 4, which is right there. And then we're going to go 8, 4. So we're 8 and 4. And then last 8, 8. I'm going to pick a different color. Let's use this ugly brown or orange, whatever we're going to call it. So we definitely have some kind of dilation going on here. But are these 2 similar, and how will we figure that out? We'll just do the math. Notice how our shape got bigger from the origin. We have our smaller shape, it got bigger. So what we're going to do is just do the math. We're going to put whatever value we had from the big triangle over the value of the small triangle. So we're just working on these ordered pairs here, which gives us 2. 4 over 2, well, that is another 2. 8 over 4, that's another 2. 4 over 2, well, that's just another 2. 8 over 4, I'm seeing the pattern here. 8 over 4. So the answer is yes. We do have similar triangles because they have a scale factor of 2. And really, we didn't really need to draw these triangles, but they help us visualize. All right, let's move on to the next one. What about this guy? Mark the triangles to show side angle side. And they already marked one of the angles. I'm gonna go ahead and pause, see how you can figure out how to mark this. Okay, let's come back to this. I think the most inclination a lot of people have is to go ahead and do the old congruency marks that we've been doing all year. That is true. All right, we can say side angle side because the scale factor, if we're doing that, is 1, right? If they have the same congruency, then it's 1. But they don't have the same congruency. There's actually something going on here. We can see that from this smaller piece to going to this bigger piece. So we don't have congruency going on here. We don't have a scale factor of 1, but they want us to show something in order to say that we have side angle side. And by definition, side angle side means that we have 2 proportional sides and an included angle. So come up with a number that will be proportional. Like, well, let's come up with this one, right? Let's just say, and you can be not that inventive, but let's just say that this side here is 3. Okay, and then this side here is 6. Not that inventive, right? And we can say that we want to stay with the same proportion. So we know that this is going to be 6/3, leaves us with 2. How about we call this side 4 and this side 8? Because we came up with a scale factor of 2, which is greater than 1. So 6/3 is 2, and 8/4, oops, forgot to write my 2, and 8/4 is 2 as well. So we can see that the proportions are the same. We have an included angle. Therefore, we showed a diagram that is showing side angle side similarity. Let's look at the next one. Mark the triangle showing side, side, side. And we can use the same strategy. So go ahead and try that out on your own. Okay, we're coming back here. And I'm going to do the same thing, right? I'm going to say that this side was, and I'm trying to line up my sides because I think this side corresponds with this side. That's the smallest side. So I'm going to call this side 2. I'm going to call this side 4. I'm going to call this side 4. Notice I'm sticking with that theme of 2, keeping the numbers nice and easy, even. And then how about 10 and 5, right? 4/2, well, that just leaves us 2. 8/4, that gives us 2, and 10/5. And if we wanted to go the other way around, it's going to be a scale factor of, you can either say this is a scale factor of 1/2. You might say, hey, we're going from this triangle, the bigger triangle, to the smaller triangle. Or you can just say, hey, look, I got a scale factor of 2, or whatever number you chose. But the numbers show that, hey, they're proportional. Therefore, we have side, side, side. Let's look at this one. Mark all the sides to show the scale factor of 4. So this is going to take a little bit of work, and we're going to mark all the sides. Now we have some angles. Is that going to be useful? Don't assume anything. I'm just going to go off of this angle. We can go We can go side angle side, or we can go side, side, side on this, depending on how you want to go about this. I'm going to focus on side angle side. If its scale factor is 4, then we can say that this side is 16. This entire side is 16, and this small side is 4. That'll work, right? 16 over 4 equals 4. And you can do the same thing on the other side if you wanted to. Like I said, I'm coming up with real inventive numbers, right? But it has to be proportional. In order for this to be side angle side, these sides have to be proportional. Looks like we got an isosceles triangle. Whatever you come up with, make sure that you came up with a scale factor of 4. So find the height of the tree. So if you notice that we got 2 triangles going on here. There's your hint before I get you started. So go ahead and get started. All right, let's go ahead and try to solve this. If you remember on Thursday, recommended that you redraw your triangles if you can't see this. So I'm going to redraw the big triangle, because we do have this big triangle starting from this very point on all the way to the tree straight up. And then we have this smaller triangle, which is person with the backpack on. Looks like they're going hiking. And these 2 triangles are sitting on top of each other, but if you can't see it, go ahead and just redraw them, because we have the small triangle and the big triangle. This will keep you from making silly mistakes. So we know the distance from the tree to the very point, that's 28. And the distance from the person to the point, that's 8. And the height of this person is going to be 5. And we want to know the height of this tree. We're going to stick to this x prime. So I know that this x prime has to be proportional to the 5. The 28 has to be proportional to the 8. And you go about, you can find scale factor doing this, or you can set up proportions. I tend to like the proportions better because that's just the way I work. If scale factor works for you, so I know I'm going to look for that bigger piece. So I want to find a scale factor of bigger than 1. So I'm going to go with 28 and equals x prime over 5. And just cross multiply these out. So what do I have here? 28 times 5. That gives me 140. I'll write that down over here. And equals 8x prime. And then we just divide 8 from both sides. 17.5. So this x here is 17.5. Right. They didn't tell me to round it to the nearest 10th. So I'm just going to stick with that decimal. So write a similarity statement that shows the proportional sides of triangle ABC is similar to triangle DBC. Well, let me give you a little bit of time to do that. All right. So we have triangle ABC. and triangle DBC. And what they want is some kind of similarity statement that shows the proportional sides. That's all they want. And so we can just use, oh, I forgot to write the C. We can just use this statement to do that. We'll start with my first two. So we went from ABC to DBC, DBC being, did I write that right? DBC, wow, that's interesting, it's DBC. So let's call it DBE, just so you're not confused, because we want to talk about the little triangle, right? Not the little triangle that's long-tailed as C. So that must have been a typo. But all right, so we're going from the big triangle to the smaller triangle. So I'm going to write these a little bit different because it looks like we're going smaller. So I'm going to go DB is proportional to AB, just like we do with our congruency statements. But we're just setting them up in proportions. BC is going to be congruent to BE. And then our last one is AC and DE. So we're going to go DE. Yeah. Writing with the mouse is hard. So there is our proportional sides. And of course, if you wanted to go a little bit further, then you can also say that angle A has to be congruent to angle D. And angle B has to be congruent to angle B. And then angle C has to be congruent to angle E. And that's what we have to write in order to say that these two triangles are similar. But in our question, they only asked us to talk about the sides. Go ahead and try out this quiz. I'll give you some time, and then I'll work through it. Okay, if triangle ABC is similar to triangle GFD, then which statement is true? Let's see. Angle A is similar to angle B. I don't like this wording, I'll be honest with you. It should be angle A and angle G. They both line up, so that's true. Let's see if we have to click more than one. Angle A and F, well, A and F are in two different parts of this, so that wouldn't count. Angle A and D, angle A and D are in two different parts. Angle A is part of the first part. Angle D is part of the last part of that statement, so I wouldn't mark that. Angle F is similar to angle C, two different parts. So the only option is angle A is similar to angle G, and it should say angle A is congruent to angle G. A little bit of a typo on this creator's part. Let's go to the next one. If two triangles are similar by the side angle side, then which of the following is true? Both sides and included angle are congruent. That could sometimes be true. Both sides in proportion are proportional. And included angle is congruent. Yes, that is true. That is by definition side angle side. The angles, well, you need a little bit more. and the only one side and two angles are known. Well, that gives us angle, angle, side, and that's not one of the postulates that we need to know. So our only option is this one here, B. All isosceles triangles are similar. Well, what do we know about isosceles triangles? That they have congruent sides and they have congruent base angles. Now, unless they have the same exact angle for all isosceles triangles, which is not the case, isosceles triangles can have different length sides, different angles. They're not like equilateral triangles. So that answer is F. False. Which of the following does not prove triangle similarity? Well, I know AA similarity. All I need to do is show two corresponding congruent angles. All I need to do is show three proportional sides. So that's SSS. And I need to show two proportional sides and an included congruent angle. So that's side angle side. So it's got to be D. So in the image provided, if two triangles are similar, which statement's true? So let's move my shining face here. So if these two triangles are similar, that means 30 should map on to Y and X should map on. So it looks like we have a rotation going on here. So X should be 50 and Y should be 30. There we go. A triangle with side lengths of 3 centimeters, 5 centimeters, and 9 centimeters is dilated by a factor of 4/3. Which of the following is not a side length in the new triangle? So what you're going to need to do is a little bit of math, pull out some scratch paper. If you're using your calculator, 4 divided by 3, well, that decimal is 1.33333. It's a long decimal. Just multiply out the sides. So I'm going to multiply that by 4. Excuse me, 3 centimeters. And what do I get? Well, I get a 4. So that eliminates A. Well, let's do that again. Times 5 centimeters. 4/3 times 5 centimeters gets me a 6.66666 and then a 7 at the end. So it looks like we rounded it. So that's C. That eliminates C. Let's do it again. 4 divided by 3 and times it by 9. That gives us a 12. So the scale factor of the dilated triangle is going to be 4, 12, and 6.67. So guess what does not belong? 3.75. So this one I need to do a little bit of work on. So a tree casts a shadow of 45 feet long and 6 feet tall. And a 6 foot tall person standing near the tree casts a shadow of 16 feet long. How tall is the tree? Let's go into my DotCam. So the tree cast a shadow of 45 feet long. So let's draw a picture of a tree. And I know I am not going to win any awards for being an artist. Okay, there's a tree and it casts a shadow of about 45 feet long. Okay, and there is a person standing near the tree who cast a 6 foot long shadow. So there's my person. And we know that distance from here to here is 6 feet. Oh, sorry. The person is 6 foot tall. and the shadow is 16 feet. Cast a shadow 16 feet long. How tall is the tree? So I want to find the height. So we do have similar triangles going on here. Just think in terms of that. We've worked several of these. Set up your proportions. You can find a scale factor to do this. Let's do the scale factor. I did the proportions last time. So our scale factor in this case here is going to be 45 because I'm looking for a big number. And just be careful, right? 45 is the distance from here to here. So take 16 out of that. Well, hold on. I don't need to take 16 out of it. I got 16. So I have 16. So 45 and 16. 45 divided by 16. My scale factor is pretty big. 2.8125. I'm going to multiply that by 6. So I got multiplied it by 6. My height is something like 16.875. Did they ask us to round it to the nearest 10? No. But the only thing I do have that comes close to that, so I got to round it up. So I'm going to go 16.9 to the nearest 10, because if I got 16.875, I am going to go to the nearest 10th. So the 7 is higher than 5, so this rounds this up to 9, 16.9. That's how I did that. Let me find my Nearpod again. There he is. All right. I got them all right. Hey, you know, I gotta admit, I had some doubts. I had some doubts that I did some of the math wrong. You've had me all year, and you know, I do my math wrong sometimes. But just think about how it went about. If you want this last part of the Nearpod, what questions do you still have about triangle similarity? Email me with those, or you can do this. I can check back later, but then email me and says, hey, Mr. K, I put a comment in on the Nearpod, and I'll go in and read it and try to respond to you. All right, so that's all I have. Tomorrow's the big final, and just keep in mind, you don't have to take this final. Your grade cannot go lower, it can only go up. And people always ask me, what can you do to, what can I do, Mr. K, to bring up my grade? Well, here it is, right here's the final. This is your last chance. So hopefully tomorrow goes well for you. And if I'm not in class and you have any questions, try to email me. I'll try to help you if I can, but just remember, I'm gonna be super, super limited if I'm tied up in this jury duty thing that I have to do. All right, guys, that's all I have for you. Good luck.